Imagine carving a highway straight through a mountain, or building an underground river beneath a city that never sleeps. Tunnels make it look effortless, but behind the scenes, there's some of the toughest, most precise engineering projects on Earth. These hidden passageways don't just move cars and trains, they deliver water, power, even the internet, quietly holding our modern world together. And yet most of us never give them a second thought. Today, we're going underground to uncover what makes modern tunnels true engineering masterpieces. The battles beneath our feet, the machines that reshape the Earth, and the innovations building a faster, safer, and smarter future. You've probably passed through one of these engineering giants today without even realizing it. Tunnels aren't just dark holes carved into the ground. They're the silent arteries keeping our cities alive. Think about Tokyo, where millions of commuters vanish underground every single morning, moving through a subway web so complex it looks like neon spaghetti buried beneath the streets. Or Switzerland's Gotthard-based tunnel, slicing straight through the Alps to connect countries faster than ever before, with trains roaring through at incredible speeds. Even in New York City, century-old water tunnels still deliver life itself, fresh drinking water to millions without a single person ever seeing them. And maybe that's the real magic. They're so reliable, so flawless, we forget they even exist. But building something this invisible is anything but simple. To understand how these lifelines are made, we need to dig much, much deeper. Digging a tunnel isn't just carving a straight path through the ground. It's going to war with the Earth itself. Every single tunnel is a unique battle. One project might face solid granite that grinds machines to dust, while another hits soft, shifting soil that threatens to swallow the entire excavation. And then there's water, always seeping in, always pushing back with crushing pressure. Add the heat rising from deep underground, and it's like working inside a hostile planet core. Engineers can't afford to guess. One miscalculation, and an entire section can collapse, costing lives, billions of dollars, and years of delay. Precision isn't optional, it's survival. That's why every tunnel begins long before the first scoop of dirt is removed. Months, sometimes years, are spent studying geology, predicting how the ground will behave, and planning every meter of the route. Because when you're fighting mountains, rivers, and gravity itself, the margin for error is zero. To conquer the Earth, engineers turn to machines that look like they came straight out of science fiction. Meet the tunnel boring machine, or TBM. Imagine a steel giant, the length of a football field, grinding through rock with a spinning head so powerful that it can carve out a new underground world while building the tunnel walls behind it as it goes. These machines don't just dig, they create an entire subterranean highway in one continuous motion. But muscle isn't enough. Modern tunneling is driven by brains, sensors, AI, and real-time data that read the ground ahead like an X-ray. If there's a hidden pocket of water or a sudden change in soil density, the system reacts instantly to prevent disaster. Even the materials have evolved. New self-healing concrete can seal its own cracks, while smart composites make tunnel linings stronger and longer lasting than ever before. Every breakthrough pushes construction faster, safer, and deeper than anyone thought possible. Tunnels aren't just about today's traffic jams or train routes, they're shaping the future of how we live and move. Picture traveling at 600 miles per hour, underground. Projects like the Hyperloop aim to make high-speed, low-friction travel a reality, zipping passengers between cities faster than airplanes without ever leaving the ground. As urban areas run out of space, cities are starting to build downward, entire layers of infrastructure, utilities, and even potential living spaces buried below the surface. It's not just about convenience, it's about survival. With rising seas and extreme weather, tunnels are becoming tools of climate defense, redirecting floods, storing renewable energy, and protecting millions of people from natural disasters. What used to be simple passageways are turning into the backbone of resilient, future-proof cities. Every tunnel is more than concrete and steel. It's proof of what human ingenuity can achieve when vision meets determination. These underground giants demand thousands of skilled hands, years of planning, and technology pushed to its limits. They're monuments to collaboration, precision, and relentless innovation, even if most people never notice them. And the work never stops. New ideas, smarter machines, and stronger materials continue to push the boundaries of how deep, how long, and how complex tunnels can become. So the next time you glide through a tunnel without giving it a second thought, remember, you're passing through one of the greatest engineering achievements of our time. Silent, hidden, and utterly extraordinary.